So today we're going to look at transformations of formula. We're going to start off with a simple, kind of more visual problem, and then we're going to work through two examples. So just example 1 says, given the following, set up an equation for solving the area. Okay, well, hopefully you remember that the area of a rectangle is equal to base multiplied by height. So they've given us our base, and they've also given us our height. So I'm simply going to substitute this in for base and height. So my base is 2a plus b, and my height is just 2a. Alright, so part A is done. I have set up the equation for solving the area. Part 2 says if a equals 2 and the area A is 32, solve for b. So solve for b, all it's telling you is I want to know what b equals given these two pieces of information. So if I write down my equation, I have a is equal to 2a plus b multiplied by 2a. Wherever I see a little a, I'm going to substitute in 2. Actually, sorry. I'll use a different color there. So wherever I substitute in, wherever I see a little a, I'm going to substitute 2 in. Wherever I see big A, I'm going to substitute 32 in. This is really important. In math, case, oops, I put a little e there. In math, case matters. Just like in English, if you start a sentence, you start it off with a capital A, you don't start it off with a small a or a lowercase a. Case really does matter in math as well, so be very careful with your cases. Alright, so big A is 32. Little a, now remember this is 2 multiplied by a, so I have 2 multiplied by 2 plus b, and this is 2 multiplied by 2. So if I simplify this, I have 32 is equal to 4 plus b multiplied by 4. Now remember here you have to distribute. So we have the 4 not only multiplies the b, it also multiplies the 4, and I get 32 is equal to 16 plus 4b. Remember, my goal is to solve for b. I want to know what b equals. So I'm going to subtract 16 from both sides. I'm running out of room, so I'm just going to write it over here. And I get 16 is equal to 4b. Now I have to get b equals, so I need to divide by 4, and then I get 4 is equal to b. So I've done what the question asked. It said solve for b. Alright, now another piece of information that you guys need to know is we call the letter that we are solving for the subject of the formula. Okay, and this is really important in physics and chemistry. I'm not a big biologist, so I'm not sure, but in chemistry and physics, you're always going to have certain variables that are known and certain things that are unknown. So variables that are unknown are what you're going to be solving for, or are subject of the formula. And so that's what we're doing here. So it says in example 2, make x the subject of the formula. This is saying solve for x. Now we have 2 x's in this one, so that's a little confusing. And remember, my goal is to get x equal to something. So I can't have the x on the bottom. So my first thing is, okay, well, I know that if I multiply the top by 2 minus x, then I no longer am going to have this piece on the bottom. This is going to become 1, which means now I have 2 minus x multiplied by y is equal to x. Alright, well, I now have all of my x's on the top, so that's a good start. However, I have an x over here and an x over here. I can't simply just add x, because what this is saying is y is multiplied by everything inside of there. So in fact, I'm going to distribute, and I get 2y minus xy is equal to x. Alright, so this is starting to look a little bit more of what I know. Notice that I've got my x's over here and here. Let's get all of my x's onto one side. So I have minus xy on the left-hand side. If I add xy to both sides, then what I have is 2y, now a minus xy plus an xy. So we're doing minus something and we're adding that same something, which makes that equal 0. And on this side, they're not like terms, so I can write them like this. I can't add those two things together because they're not like terms. However, they have an x in common. So guess what? I'm going to factor that out. Now be really careful here. When I factor an x out, x divided by x equals, I really hope you said 1, because it equals 1. Be really careful with that. Now, I'm getting closer. I have my x isolated, but there's this piece that's making it not be all by itself. So if I divide both sides by 1 plus y, remember something divided by itself, over here we've got 1 plus y divided by 1 plus y. These are going to become 1. And so I'm left with 2y divided by 1 plus y. You can put the brackets in. You don't have to put the brackets in. It's up to you. Either are correct. And on my right-hand side, I have x multiplied by 1 over 1, which is just equal to x. I now have x equals something. So I've found my solution. All right, we have one more example. So example 3 says express v in terms of f and u. So express v in terms of f and u. This express v is saying solve for v. So I want v equals something. There we go. We're gonna find the lowest common multiple of u, v, and f. Alright, so I hope that we're okay with this still. If I'm trying to find the lowest common multiple of this, it would be u multiplied by v multiplied by f. And remember, our goal is to get v equals. So this is why this method works so well. So I'm going to multiply both sides by VUF, and I have 1 over u plus 1 over v is equal to 1 over f. Now remember, this is the same as UVF over 1. We have to distribute this. Okay, it's really important. Everything on the left-hand side is being multiplied by UVF. And we're adding these things. UV, oh, that looks kind of like a U. UVF over 1 multiplied by 1 over v. Oh, and I forgot up here to write, we're also multiplying this side, UVF over 1. So this is going to equal 1 over f multiplied by UVF over 1. Remember, I forgot to put this in, but whatever I do to one side of the equation, I also have to do to the other side of the equation. So make sure that right away you write it's multiplied. Everything on the left-hand side is multiplied by UVF. Everything on the right-hand side is multiplied by UVF. Alright, when I do this now, I can start to make things cancel. So notice that here I've got a here I've got a u on top, and here I have a u on top. This is really nice. I can cancel those. They become 1, and I'm left with VF plus, now over here I've got a v and a v, and I can cancel these because all that's happening between them is multiplication. So I have UF. Now on my right hand side I have an F and an F, so those are going to cancel. They become 1, and I'm left with UV. Alright, so at this point you might be like, what are we doing? If you ever get to that point, go back up to the question. Express v in terms of f and u. Okay, I'm trying to solve for v. So I'm going to come down here, and just to remind myself, I'm going to highlight stuff. Alright, so I need to get all of my v's on one side. Now, it doesn't matter which side you go. I'm just going to do it the most simple way. If I subtract VF from this side, and I subtract VF from this side, all that I'm left with is UF on this side, because something subtract itself is 0. So this is equal to 0. And then over here I've got UV minus VF. They're not like terms, so I can't simplify them. However, they both have a V in them, and therefore I can factor that out. Again, I'm trying to make my equation look like V equals. I'm solving for V. And therefore, if I divide both sides by U minus F, then notice that this divided by itself is 1. So what I'm left with is UF over U minus F is equal to V. And that is my answer. I have V is equal to something.